So I'm asking you to calculate x squared plus y squared. What you're going to get is 1. If I take 0.6 squared plus 0.8 squared, assuming I didn't screw up in my head, you get exactly 1. So when I made up those numbers to put there, I can't just put any numbers. If I would have said 0.6 comma 0.9, 0.6 comma 0.9 would be here, and it wouldn't be on the unit circle. So that's the equation of the unit circle, and that's the interpretation about what it means. It means if you take the x and y coordinates and square them and add them, you get 1. If you don't get 1, it's not on the unit circle. B says we have a circle centered at the origin with a radius of 3. Determine the equation of this circle. Well, the only difference here is going to be that we're still going to start off with x squared plus y squared equals the hypotenuse squared. But if I take a look at my circle, and I'm going to erase this so it doesn't matter how nice or ugly it is, this distance is 3 because the radius is 3. So the hypotenuse on our right triangle is 3. And we're going to end up with x squared plus y squared is equal to 3 squared. Or x squared plus y squared equals 9. So in general, what is the equation of the circle whose radius is r if it's centered at the origin? X squared plus y squared equals r squared. So that's a brief overview of circles centered at the origin, but the one circle we probably want to really concentrate on is the unit circle. I'm going to pause there and ask if anybody has any questions so far. All right, let's take a look at some examples then. The x-coordinate of a point on the unit circle is 3/4. What are the y-coordinates? Now that's interesting because it doesn't say what is the y-coordinate, it says what are the y-coordinates. Let's solve this by using the formula for the equation of a unit circle, x squared plus y squared equals 1. It's on the unit circle. If it's on the unit circle, x squared plus y squared is equal to 1. So I can put in 3/4 for x. I have to square that, and I'm putting it in brackets. Plus y squared is equal to 1. I square 3/4, so I want us to work on paper. I don't want us to work on the calculator just yet. When I square 3/4, I get 9/16. I square 3 and get 9. I square 4 and get 16. This is equal to 1. My mind immediately says 1 is 16/16. Because I'm about to subtract 9/16 from 1, I want to think in terms of a common denominator. So I'm going to have y squared equals 16/16. That's what I'm doing. I'm converting 1 to a common denominator of 16 minus 9/16. And if I had, 16 puppies minus 9 puppies, I'm going to have 7 puppies. If I have $16 minus $9, I'm going to have $7. How's my arithmetic so far? Any problem with it? I think that's right. So now what I'm going to get is y squared equals 7/16. So then you take the square root, and you have y equals the square root of 7 over 16. The square root of 7 is just root 7. We don't want to mess with that in decimal form. And the square root of 16 is 4. Anybody want to volunteer what I've done wrong?
Plus or minus?
Excellent. Was that you, Aaron?
Yes.
Okay, perfect. Plus or minus. So we legitimately, whenever you go plus or minus, you need to determine whether that's a legitimate thing or not. And this is, because when you take a look at an x coordinate of 3/4, this is about a half, this is 3/4 right there. There are two places that have that x coordinate of 3/4. One of the places has an x coordinate of 3/4, but the y coordinate will be positive √7/4. And the other one will have coordinates of 3/4, comma, negative √7/4. So the mathematics doesn't lie. If the mathematics says plus or minus, you're going to have to ask yourself whether there is in fact a plus or minus. And in this case, there is. So those are the coordinates of the points. We are also asked to sketch, I believe, the rotation angles. Because there are coterminal angles involved, potentially, we could label these angles in any particular way we wanted to. We could label this as theta. We could label that as theta. I'm not saying we want to do what I'm about to do, but if you wanted to, just because you want to be different, you could label this as theta. It's going to be a different angle, but it still has the same terminal point. So it's a coterminal arm. You could over here say that this, don't do this. You could say that that is theta. It's not wrong. I would always recommend going with the smallest positive angle that will take you there. So any questions with that example? All right, the next one, number 2, the y coordinate of a point on the unit circle is -1/√2. We have to discuss something right now. We might as well get it out of the way. I'm not going to worry about the negative, but take your calculator and calculate what 1 divided by the square root of 2 is. I'll do it up here, just in case somebody doesn't have a calculator. So 1 divided by the square root of 2 gives 0.7071. And I would like you to calculate the square root of 2 divided by 2. And when you calculate the square root of 2 divided by 2, of course, you're going to have to make sure that you close the brackets on the argument of the square root before you go divided by. Otherwise, you'll be taking the square root of 2/2. 2/2 is 1, so you'd be taking the square root of 1, but that's not what we want. We want to find this. And the lesson learned here is that 1/√2 is exactly the same as √2/2. If you want to know why, this goes back to math 20 and 10. When you have a radical in the denominator, we typically do not like it that way, so we rationalize it. We multiply the top and the bottom by √2. And when I multiply across the top here, 1 times √2 is √2, and across the bottom, √2 times √2 is just 2. So, what's my point? My point is, from here on in, when you see this, or you see this, you recognize they're the same thing. It's like hello and bonjour, if you speak English and French. They mean the exact same thing. Okay, the y coordinate of the point on the unit circle is -1/√2, and the point is in quadrant 3. So if the point is in quadrant 3, this is different than the previous question. I believe 1/√2 was 0.707, so -0.707 is someplace around here, roughly. So that y coordinate is -1/√2. And there are 2 points with that y coordinate. But since you're told the terminal arm or the point lies in quadrant 3, you know that it's only the point on the left. And this is something you're going to have to get used to. I just want to clean this up a little bit. This is something that you are going to have to get used to, looking in the quadrants to decide based on positives and negatives for x and y where this point is. So we could actually draw this right now. This is what the terminal arm looks like. This is how we could draw the rotation angle. But now we want to find the x coordinate. We're going to take x squared plus y squared. We put the negative in, equals 1. We end up with x squared plus 1 over 2. I mean, think about that. I square negative 1, I get positive 1. I square root 2, I get 2. This is equal to 1. So x squared is equal to 1 minus a half. 1 minus a half is a half. So x squared is going to be equal to 1/2, which means x equals plus or minus the square root of a half. So x is equal to negative 1 over root 2 or positive 1 over root 2. I'm taking the square root of the 1 to get 1, and for the square root of 2, I leave it as root 2. What I want to draw your attention to, oh, by the way, this one is out because it's in quadrant 3, and in quadrant 3, x is negative. So the actual x coordinate is this. But what I want to draw your attention to is the fact that the x and y coordinates of this point, forget about negatives, are the same value. And with a little bit of thought, I hope it's obvious that if the x and y coordinates are the same value, these two angles have to be equal, which means you're talking about a 45-degree location in quadrant 3. So the x coordinate is negative 1 over root 2, and there's a diagram showing the rotation angle, the point, and the terminal arm. Any questions with that example? All of this is just parsley on the fish. It's got nothing to do with the question. There is our answer. All right, let's move on. A circle has a radius of 5 with its center at the origin. The x coordinate of a point is 3.2. What are the y coordinates? Well, it's x squared plus y squared equals r squared. Now, this is not a unit circle because the radius is 5. And if the radius is 5, the equation of the circle is going to be x squared plus y squared equals 5 squared. So x squared plus y squared equals 25. Now, I don't normally say this, but we'll just shave a couple of minutes off this. Since this x coordinate is given in decimal form, let's calculate the y coordinate in decimal form. What that's going to mean is it's going to be rounded and it won't be an exact value, but that's okay. We can have 3.2 squared plus y squared equals 25. So we need to figure out what 25 minus 3.2 squared is. So we get, well, it might actually work out nice. Let's go exact value. We get y squared equals 14.76, which as a fraction is 369/25. Let's go with exact value. Y squared equals 369/25, which means y is equal to plus or minus root 369 over 5. I'm taking the square root of 25. I want to be careful here not to make things too simple just because we're learning at home. You should be able to simplify root 369 because I believe, looking at the number, that 9 divides into 369. And I believe it's going to divide in 41 times. I'm pretty sure, but based on my track record this morning with mental math, I was pretty off base sometimes. So I'll just check. 369 divided by 9. No, it is 41. And that means that y is equal to plus or minus root 9 root 41 over the root 25. Y is equal to plus or minus 3 root 41 over 5. Now, we don't actually need to calculate what that value is to plot the points accurately. The x-coordinate was 3.2. I'll just check. Yep, the x-coordinate was 3.2. So I would judge 3.2 to be about here, approximately. I mean, we don't have to be precise, which means that 3 root 41 over 5 has to be this y-coordinate, and negative 3 root 41 over 5 has to be this one. I mean, we could calculate what that is and see if it looks right, but I don't think we need to. Let's draw in our rotation angles. Let's label the actual, so those are the terminal arms. Here is the angle. Here is the angle. We can put the coordinates 3.2 comma negative 3 root 41 over 5 and 3.2 comma positive 3 root 41 over 5. So that finishes that first set of examples. Any questions with any of those? Okay. So now you're going to have that unit circle handout in front of you. You were looking at this handout while you were looking at the lesson. So the first thing is, what does this notation mean? P brackets some angle. Well, I'm telling you what it means here. If I said P brackets 30 degrees, that's P of a function of 30 degrees. It's simply the x and y coordinates of that point. So if I said to you, I'm going to go to this handout now. If I said to you, what is P of 0? You should know that it's 1 comma 0. Right? I mean, we should know that because it's a unit circle we're looking at here. So that's what that notation means. Okay, now back to the handout. What are the values of P of 0, P of pi over 2, P of pi, P of 3 pi over 2, and P of 2 pi? What I am asking you is what are the coordinates of this point, this point, this point, and this point. And by the way, P of 2 pi would be the same as P of 0. Let that sink in. This point right here is the point of 0 radians, and this point right here is also the point at 2 pi radians. So P of 0 and P of 2 pi are equal because 0 and 2 pi are coterminal. So what are the coordinates? Well, at 0, the x-coordinate is 1 and the y-coordinate is 0. At the top of your circle, so you're looking at your handout, your other handout, at the top of the circle where pi over 2 is, the x-coordinate is 0 and the y-coordinate is 1. On the left-hand part of your circle, which is over here, since the radius is 1, the x value at that point is negative 1, and you can see the y value is 0. So this is negative 1 comma 0. When you get to the bottom of your unit circle, P of 3 pi over 2 would be 0 for an x-coordinate and negative 1. And then P of 2 pi, I'm not even sure why I put it in there, it's back to 1 comma 0. And it says label these coordinates on the sheet that you're looking at. I just want to double check to make sure that when things went from my mind to my hand, I wrote down the correct thing. 1, 0, 0, 1, -1, 0, 0, -1, those are all right. So if you look up here for help, there's the first point. P of 0 is 1, 0. P of pi is -1, 0. I'll go full screen maybe to make it a little bit bigger. When you look at the top, I now have P of pi over 2 equals 0, 1. And at the bottom, I have P of 3 pi over 2 equals 0, -1. Any questions with those? I got a problem here with it jumping ahead. That's okay. Any questions with those sets of points? Okay, so now all we have to do is label the coordinates of the other points, which is a little trickier. And if you had me for Math 20, I would have done this with you, and it would have stressed you out at the time, and I would have said it's not a big deal, it's just to prepare you for 30-1. So we want to know the coordinates of this point at pi over 6. And I hope that you recognize this triangle I have is the triangle that fits in here. So if you can determine, looking at this triangle, which has a hypotenuse of 1, if you can determine the base and the height of it, you will determine the x and the y coordinates. I don't expect too many people to remember how this is done, but if I take this triangle, and let's talk about degrees for a second. This is 30 degrees, which means this must be 60 degrees. Let that statement roll around in your head for a bit. If that small acute angle is 30, why is the larger of the acute angle 60? Well, those two small angles have to add up to 90 in a right triangle. So that's where I'm getting 60 from. If I take this triangle and I flip it vertically and ignore all of the crap that goes with it. So I'm not interested in this x or what this thing is in here. I'm not interested in any of this stuff. But what I discover is that this is 60 degrees, which means this is 30 degrees. But more importantly, this is 60 degrees. I am looking now at a single triangle that is equilateral because it's a 60, 60, 60 degree triangle. Now, if it's equilateral and this length is 1, that must mean that this length is 1. And since this side is equal to this side, each of those two short sides must be 1/2. So what have we learned? We learned that y is a half. Now how do we find x? We use the Pythagorean theorem. X squared plus y squared equals 1 because it's the unit circle. When I square 1/2, I get 1 over 4. I square the 1 to get 1. I square the 2 to get 4. Which means x squared is 1 minus a quarter. And if I give you a pizza, but I've eaten a quarter of it, then you have 3/4 of a pizza that you're looking at. Which means x equals the square root of 3 over the square root of 4, which is 2. And we're in quadrant 1 here on this diagram, so x is root 3 over 2. It's positive. The coordinates of this point are 1/2 comma root 3 over 2. And here's the catch to this lesson. You need to know that. You need to know that at 30 degrees, I wrote them backwards. You need to know at 30 degrees, and I knew I wrote them backwards because I was just going to say at 30 degrees, the y coordinate is a half and the x coordinate is root 3 over 2. It's something that you just need to know. Okay? Now, at the end of all this, I'm not going to pause and ask for questions for a little while yet, because at the end of all of this, I'm going to teach you other ways that you can know these numbers. Let's take a look at the next one where we have pi over 4. We want to determine the coordinates of this point up top. So I've peeled this triangle off and I've made it bigger. Well, if this is a 45-degree triangle, then this must be 45 degrees as well, and that tells you it's isosceles, which means this side and this side are equal. I could call them both x, I could call them both y, but I'm just going to call them a. What this means is that a squared plus b squared equals 1, which means, well, they're both a. A squared plus a squared equals 1. They're both the same number because the sides are equal. I get 2a squared equals 1, which means a squared is 1/2. So each of these is 1 over root 2. I take the square root of 1/2, which gives me the square root of 1 over the square root of 2, which is 1 over root 2. I hope, in fact, you remember from a previous example that when you are at that position that's the same angle away from both axes, the coordinates of the points are the same. So we know the coordinates of those. 1 over root 2, comma, 1 over root 2. Or root 2 over 2, comma, root 2 over 2 is the same thing. Just a quick question, because I think it will help. Too fast, too slow, just right, please, everybody. All right. I have some intuitive nature to the speed that I should be going at. By the way, over here, I guess I should have written p of pi over 6 is root 3 over 2, comma, 1 over 2. Take a look at this diagram right here. Notice that when you have a 30-degree angle on the unit circle, the opposite side is 1/2. Let's take a look now at the next one. Again, this is the 60-degree angle. I've taken this triangle and I've peeled it off of here. But do you notice that this triangle is the same as the triangle for the 30-degree one? It's just that it's oriented differently. I hope you notice that. I'm not going to go through the calculations again by reflecting this to produce an equilateral triangle. This will be 1/2 on the bottom, and this will be root 3 over 2. 1/2 and root 3 over 2 on the unit circle are like peanut butter and jam. They go together. You see a coordinate, whether it's x or y, and the coordinate is 1/2, the other coordinate is root 3 over 2. You see a coordinate of root 3 over 2, the other one is 1/2. So this is 1/2, comma, root 3 over 2. Now, before I go on, I want to show you how I know these three sets of coordinates. So I'm going to flip back and forth between them. And I'm going to maybe just move some pages. That one and... Okay. So what you're looking at here are the coordinates at the 30-degree angle. In fact, you know what? No. Let's put them on our unit circle. So if you look, I'm going to be drawing on this and then stuff will be disappearing. The coordinates of this point are root 3 over 2. I'm going to make this a little larger still, even though some of it will be off the screen because I want it to be as large as possible. So this is root 3 over 2 comma a half. Let's label in now that point. So this point is root 2 over 2 comma root 2 over 2. Again, you need to know these. The next point is 1/2 root 3 over 2. I'm going to give you a second to write those coordinates down, and then I want to explain to you how I know what they are. All right. So what I remember, I memorized the fact that at the 45-degree interval, the x-coordinate and the y-coordinate have to be equal because it's at 45 degrees. It's halfway in between. What I've just drawn is a square. So I memorize that for those, it's going to be root 2 over 2, root 2 over 2. So for example, over here on the left, I know this is going to be negative root 2 over 2, comma, root 2 over 2. It's the same set of numbers, except x is negative. Okay, I know that. I'm going to erase that now. Then I say, and you have to listen and think at the same time. I say, I know that the other points are the 30 and 60-degree points, and I know that the numbers are always a half and root 3 over 2. Always. So if I don't know this, what I do is I look at this point and I look at the x-coordinate here. Now remember, this is 1. And I look at the the y-coordinate here. Now remember, this is 1. And I ask myself, which of these, the y-coordinate or the x-coordinate, which of those is half? It's very clearly the y-coordinate. If this is 1, then this must be a half. So what I do then is I immediately look at my drawing of my circle and say the y-coordinate is a half, which means the x-coordinate is the root 3 over 2. By the way, take your calculator and calculate root 3 over 2 for me. Don't forget to close the brackets on the square root of the 3. You will get for root 3 over 2 about 0.866. Can somebody confirm that for me?
Yeah, that's right.
Good. So 0.866 is almost 0.9. Now look at this. 0.866, 1. It's almost 1. So it's very easy for you to know these numbers. For example, when we take a look over in quadrant 2, as I said, well, I'll show you another one. I'll flip forward here. Why do I know that this is negative 1/2 root 3 over 2? Well, I know that, I better back up and show you something. I know that this, and this are all the 1/2 root 3 over 2 points. So when I look at this point, I go down on the x-axis and I say, well, that's a half. I hope you're getting my drift here. I can't judge the reactions on your faces, but that total distance has to be 1, so that must be an x-coordinate of a half, except it's negative a half, and the y-coordinate is root 3 over 2. Why is the y-coordinate root 3 over 2? Because whenever x is 1/2, y is root 3 over 2. And putting in the numbers. So what I'm going to ask you to do, I'll maybe do just one more. This point would be negative root 2 over 2, comma, root 2 over 2. This one would be, I mean, look at the y-coordinate here. It's a half. The x-coordinate is that negative 0.866. I'm going to give you guys a couple of minutes here to fill in the rest of the coordinates of your unit circle and ask you to type the letter D when you have done that. All right. Some people freak out about the unit circle because if you were to walk in the room or log into this Google Meet and that was the first thing you saw and I said you need to know that, that's a little terrifying. But I will set your mind at ease a bit because you don't need to memorize the whole thing. And secondly, knowing the unit circle makes your job in trigonometry a lot easier, but if you don't know it, you can still get the right answers most of the time. So what do you need to know? You need to know the exact coordinates of any point on the unit circle that is one of those special points. And now I'm going to explain why. What is the value in this other than a mathematical exercise? Well, let's go back to the handout. We've labeled everything. So we've labeled that. We've filled in all of the coordinates. Now I want you to pick a point that's on the unit circle, but I want you to pick a point that we know the coordinates of. And I want you to take the cosine of the angle. So for example, let's do this all together. Let's take pi over 3, I'm highlighting pi over 3 here, and let's find the cosine of pi over 3. That means that we need to be in radian mode because we're going to be taking the cosine of pi over 3. And pi over 3 is radians, so I go cosine of pi divided by 3 radians, and I get 0.5. Let's take the cosine of pi over 4. Cosine of pi divided by 4, and we get 0.7071. But 0.7071 is the same as the square root of 2 divided by 2. Let's take the cosine of 7 pi over 6. Sorry, I'm being lazy right now. I'm just sitting in my chair using the mouse. Let's take the cosine of 7 pi over 6. Cosine of 7 pi divided by 6. It gives me negative 0.866025. And if I take negative root 3 and divide it by 2, I get negative 0.866. What we notice, everybody, is that the cosine of the angle is the x-coordinate. So on the unit circle, cosine of theta equals the x-coordinate. And I'm going to shave a few more minutes off here because I think we're running a little bit over. If you try that with sine, you will discover that sine of the rotation angle will always give you the y coordinate. And that goes for any point. If I told you that we had a rotation angle of 100 degrees, what are the coordinates of this point? The x coordinate will be whatever the cosine of 100 degrees is, and the y coordinate will be whatever the sine of 100 degrees is. So on the unit circle, the coordinates are given by the sine and the cosine.